So good morning, good afternoon. Welcome to the Global Network webinars. My name is Alexander Loschke, and I will be moderating this webinar today together with my colleagues Sean Lovell and Panya Yu. So we are very happy to have with us today two of our colleagues here from UNSD, the UN Statistics Division. So we have Marko Javorsek with us and Bram, who will be talking about the SEEA Ecosystem Accounting and the Artificial Intelligence for Environment and Sustainability, also called ARIES, for SEEA Data Solution. In the first part of the webinar, the SEEA Ecosystem Accounting Framework, its concepts and definitions will be introduced. And in the second part, a practical demonstration of the ARIES for SEEA tool will be made. So to give you a little bit of background, the SEEA Ecosystem Accounting Framework was adopted by the UN Statistical Commission in March 2021 and generated a lot of interest beyond the statistical community. It has been identified as an important statistical framework to support the monitoring and reporting to several environmental conventions. In the second part of the webinar, we will learn about the Artificial Intelligence for Environment and Sustainability System, also called ARIES, which is an integrated open source modeling platform for environmental sustainability, where researchers from across the globe can add their own data and models to web-based repositories. ARIES allows users anywhere in the world to produce rapid, standardized, scalable, and customizable ecosystem accounts for their area of interest, and which are consistent with the SEEA Ecosystem Accounting Framework. ARIES for SEEA is available on the UN Global Platform, a cloud service platform supporting international collaboration in the development of official statistics using new data sources and innovative methods. So let me now introduce our speakers. Marko is a statistician in the Environmental Economic Accounts section of the UN Statistics Division, where he was responsible for the revision of the SEEA Ecosystem Accounting and is now responsible for its implementation, advancement of its research agenda, and for capacity development projects in several countries in Africa. Previously, Marko also worked at the UN Economic Commission for Latin America and the Caribbean, and the UN Economic and Social Commission for Asia and the Pacific. Bram is a senior statistician with the UN Statistics Division, where he is the project manager of the Natural Capital Accounting and Valuation of Ecosystem Services project, which covers several countries around the world. He has been heavily involved in the development of the SEEA Ecosystem Accounting, and prior to working at the UN, Bram worked in various roles for Statistics Netherlands, and before that, also for the UN. Now, before I hand over to our first speaker, let me just mention a few practical things. So Marko will give the first presentation, and we will stop after his presentation to see if there are any questions, immediate questions, and then we would continue with Bram. After both presentations were given, we will have a longer Q&A session at the end. So feel free to write your comments and questions into the meeting chat at any time. So this will give us, the moderators, and also the speakers an opportunity to check what questions are being asked. And later on during the Q&A session, you can also unmute yourself and switch on the camera if you like and ask the question yourself. So this might make it a little bit more lively. As always, this Global Network webinar is being recorded and will be made available on the Global Network of Data Officers and Statisticians at yammer.com/UNstats. We invite you to continue the discussions on the global network after the webinar. And now I would hand over to our first speaker, Marko. Thanks, and also Bram, thanks for joining us. Marko, the floor is yours.
Thank you, Alex. Let me start by sharing my presentation. Thank you very much for inviting us to this webinar and giving us the opportunity to talk about the SEEA. Can you now see my presentation, or can you see the full screen or the presenter notes?
I see the full screen.
Perfect.
Looks good.
Great. Thank you. Thank you for introducing us as well. So I think that has been taken care of. I will make a very quick introduction to the SEEA and the SEEA Ecosystem Accounting, because I understand that several participants in the global networks may not be familiar. So for those who you are familiar with the SEEA, bear with me a little bit, and also, well, it might be a little bit of a refresher as well. The SEEA is really coming from the need to account for the well-being and the connection and the interconnection between the nature and the economy. Things like biodiversity loss and climate change are some of the biggest challenges that we are facing, but indicators such as the GDP, we all know that, and that we might all love, but we all know very well that doesn't really account for or doesn't really provide a good picture of the interaction between the economy and the environment, or the degrading of the nature that happens due to the economic activities. So for that, decision makers really needed to account for the nature and the degradation of the environment, and the SEEA really tries to fill this gap. The SEEA, it was, I'll talk about the adoption a little bit later, but the latest adoption as Alex has already mentioned, the adoption of the ecosystem accounts has attracted quite a bit of interest from the Secretary General, as well as many other organizations and people in the world that really understood the historic step and the importance of moving beyond the GDP and the information that the SEEA provides us with. The SEEA in general is an accounting framework and uses accounting that is fully in line with the system of national accounts to integrate many data sets. If by integrating all these data sets, we can produce more robust, more of better quality and more robust information and accounts that can be directly linked to policy and can address many policy questions that we have and that are there in the world. But it is a framework that is based on accounting, based on the system of national accounts, but it really it tries to account for the interaction between the environment and the economy. So why accounts? In the past, we've had many ministries, many agencies are looking in their different areas, their different policies that are interested. They collect their data, but these data are many times not contrasted. They are not aligned, and they may not even be consistent with each other. Basic data are very important, and they are really the base of decision making. But by putting them together, but by organizing them in an accounting framework, we can derive more information, but also improve on the information and on the data that is produced. Similar to the field in the economy with the SNA, in the area of the environment, the SEEA can really provide this better and more integrated sort of source of information to derive the indicators for integrated policy. The SEEA supports many and very varied initiatives. I have to say, and the most important that obviously is to support the initiatives and decision making on a national level. But on a international level, it also supports all these ongoing initiatives, and few are listed here. The SEEA can provide information for many indicators in these various areas, and we are engaged with all these areas to make sure that the link between the SEEA and between the accounting and these initiatives is well established and seeps in through the policy. The SEEA is a little bit moving towards the statistical sphere now. The SEEA is an international statistical framework, it's the standard. It is at the same level as the system of national accounts. The SEEA central framework, the one in the middle, was adopted in 2012 as an international statistical standard, and the new part is the SEEA Ecosystem Accounting, the one on the right, that has been adopted last year by the United Nations Statistical Commission, and is really complementing the picture. The SEEA has also a number of subsystems, as we call them. Those are fully aligned and consistent with the overall standard, but they do provide a little bit more information on the particular areas such as water, energy, agriculture, forestry, fisheries, and several of them are in preparation. Most notably, let me point out ocean accounting here. That is a field and area that is gaining interest and prominence, and we are working quite heavily on that area as well. The SEEA, as I've already alluded, is really composed of two areas. So one is the central framework on the right in this, on the left in this slide, and the ecosystem accounting on the left. Those are really two sides of the same coin. They just look at the environment from a different perspective and account for the environment in a slightly different way. So in the central framework, we really look at the environment as a collection of environmental assets. So that can be the timber, the water, the fish, and so on. So these are the different assets, and we look at, well, how these assets really move from the environment into the economy, how they are consumed within the economy, and then how are residuals emitted back into the environment. So, for example, of timber is harvested from forests. Let's say it's used in production of wood products, and then at the end it can be discarded as waste or even burned, and emissions can be generated. On the other side, on the right hand side, we have the ecosystem accounting, where we look at the environment as a collection of ecosystems. So these ecosystems can be forests, rivers, coastal areas, lakes, croplands, etc. And here we really look at the services, the ecosystem services these ecosystems provide. So in the case of forest, we do not look at just the timber as such, but we look at the forest as a system that provides many services such as flood control, air purification, carbon sequestration, as well as timber provisioning, obviously. So those are two complementing parts of the SEEA, and they both together provide a complete picture on the economy. So this is the kind of overall picture, the environment nexus. This is what I talked about. The yellow part is the economy. The economy uses takes from the environment the natural inputs or the ecosystem services that also come from the environment. Then the economy obviously consumes them in various ways in production and other economic activities, and then generates residuals that are going back into the environment. So that's overall on the SEEA. And let me quickly move to the ecosystem accounting a little bit more into detail. So in the ecosystem accounting, that's the second part, the one that I had on the right-hand side. The center really are the ecosystem services. we talk about mostly about the final ecosystem services because this is an accounting framework that is concerned with the linking to the economic production. And the final ecosystem services are the ones that are directly consumed by humans, the society. So this is the sort of SEEA ecosystem accounting framework where we have. So first we start with the ecosystem assets. These ecosystem assets, such as forests, lakes, croplands, they have their extent. They are spatially identified within the environment, and they have a certain level of condition. And condition is also very important to know much ecosystem service they provide and what's the sustainability of this ecosystem service they provide. So from these assets, we do a look at the ecosystem services. We can identify a set of ecosystem services that they provide. And then the link of these ecosystem services is very important to the benefits that these ecosystem services provide to the society, the economy. So this is some sort of a chain in the ecosystem accounting that the framework really tries to account for, and it's centered around this framework. In order to do that, in order to put that in an accounting framework, there are core accounts that have been developed. So on the first side, on the ecosystems side, we have the ecosystem extent and the ecosystem condition accounts. So these accounts are stock accounts, and they really provide the information on the extent, location, and the size of the ecosystems and their conditions. Using these accounts, we can derive the flow accounts, and those are the ecosystem services flows. So which are these services? Which ecosystems provide these services? What are the values in physical terms? And who are they consumed by? So the link to the users is extremely important. The ecosystem services can be accounting for firstly in physical terms, but can also be monetized into monetary terms. And then we can use, in turn, these ecosystem services flow accounts in monetary terms to also derive monetary ecosystem assets, which are nonetheless nothing else but the sort of a net present value of the flow of ecosystem services from these ecosystems in the future. So this is sort of the chain that I was talking about. So an illustrative example of it, obviously. So for example, we have an asset, a forest. We locate it, we know the size. Then in the second step, we measure its condition. So for example, soil depth, and we define different indicators that might be of interest for this asset. And then we know what are the services that we are analyzing, that we are interested in. So in this example, it's water filtration. That's why the example of soil depth was selected in the previous condition account. There can be various number of indicators, obviously, and this is then directly linked to the benefits and beneficiaries. So if the forest provides a service of water filtration, then the clean water is the benefit that it provides. And who is the beneficiary of this? Well, it's the society, are the people downstream in the villages, in the cities, settlements, and so on. So one important link is this chain of events from, or not events, I mean chain of chain of accounting framework from the asset to the beneficiaries that are benefiting from the ecosystem service. So that's on the framework, and then let me run through a couple of examples of the accounts. So you have a little bit more of a tangible, a little bit more of a practical examples of the accounts that have been developed. So first is the ecosystem extent account. So here it's very important to understand that we have we have to define what are the assets. So those are the ecosystem assets. Those are the contiguous spaces of a specific ecosystem type characterized by a distinct set of biotic and abiotic components. So it's really important to understand that those are, like the forest is the contiguous um, space of a particular ecosystem type. So we have identified these ecosystems in a map in this example on the left, and they can be assigned an ecosystem type, which is very important. That's why I've been talking about the forests, croplands, urban lands, etc. They can be natural or as heavily modified as we may want to. We need to account for them in an exhaustive manner as well. So after that's been identified, then we can basically derive the extent of all these assets, and that is what is the ecosystem extent account. And for the account, we group them by the ecosystem type. So we say how many hectares or square kilometers, etc., of a particular ecosystem type there are in the accounting area we are looking at. Quick example from Brazil, for example, they have compiled this ecosystem extent account between 2000 2018, and quite a lot of policy information has been derived from that, as well as it has gained quite a bit of interest among in the press and so on. So this is the extent account in a tabular form. As you could see before, it can be presented in a map, because one principle of ecosystem accounting is spatial principle. The other principle is, and on the other hand, it can also be presented in a tabular form where we can see the additions and reductions of a particular ecosystem type between the years, and then we can analyze the changes and the evolution. Ecosystem condition, on the other hand, really tells you the condition of the ecosystems. And here we can, it's like going to the doctor, right? The doctor might ask several variables, are you smoking? What's your weight? What's your height, heartbeat, etc., in order for him or her to assess your health. There's a certain reference value, and based on that, he or she judges you are healthy or you're not healthy. So it's very similar. We do that for the ecosystems, and in order to do that, we assign certain indicators, certain variables. We measure them, and then we can aggregate them and present them in various forms. So this is an example of forests condition in Spain. There's several indicators that were selected. There's quite a number of them. They were measured, and then they were presented both in map format, so you can nicely see the evolution and the change between the years, and in a tabular format. They can be aggregated in various ways by assigning weights and reference values. And lastly is the ecosystem services flow accounts. So here we have in the SEEA, we have a set of 25 ecosystem services that have been defined as in a reference list. We do not have a proper classification of ecosystem services yet, but we've distilled several classifications in a reference list, and these are the 25. They're divided into provisioning. Those are the ones that have a direct link into the economy already, or into the national accounts already. There's regulating, that are extremely important, but many times we see them as free because they are not accounted for in the national accounts. And then there's obviously the cultural ones that are about recreation, education, and scientific use, and so on. An example of from South Africa in this case, for example, where we looked at This is a project that we worked on in a particular province in South Africa, KwaZulu-Natal, where they've actually compiled a set of accounts for 11 different ecosystem services between 2005 and 2011. They valued and modeled these ecosystem services in both physical and monetary accounts, and presented the results in maps. So where you have the ecosystem service, the different ecosystem services, their the values. So these are in physical terms, the provision of these ecosystem services. And this is also a supply table. So for each ecosystem type that's in column, each ecosystem services service is present. The supply of each ecosystem services is presented here in physical terms. This has also been monetized in rand currency. But what I don't have here, but it's also important. There's also a use table. So where you look at what which economic units use these ecosystem services and what are the values, again, in both physical in ecosystem and physical terms and monetary terms. So that's a very quick overview on the SEEA from a very theoretical perspective. Thank you for this. Maybe we can stop for a quick round of questions if there's any clarification questions. But I think the most important part would be then the presentation Bram will deliver on the actual ARIES work. Thank you.
Thanks, Marko, for this overview of SEEA and the SEEA Ecosystem Accounting. So maybe we can stop here, yes, for 2 or 3 minutes. Maybe we can take 1 or 2 questions. So I see in the chat a question, how can national statistical offices start to adopt this initiative? That's maybe a very good question to start with. Marko, over to you.
Sure, thank you, Alex, and thank you for the question. So first, first it's really important to identify the link to policy. So I believe it's very important for the statistical office and other agencies in country to start discussing what are the national or international policies that they would like to address. To start developing a particular. One thing I didn't mention, the SEEA is very modular. You do not have to implement everything. You can just start with a particular aspect that addresses the link to that policy. So that's obviously the first thing. Then the next step is once we identify the need and the area we want to work on, then the aspect would be to work on identifying the data sets using the using tools such as ARIES to identify to develop first-tier accounts and to generate a national discussion around this. One particular aspect of the SEEA is that many of these data sets already exist on the national level, but they sit in different agencies. And the statistical office often is not aware of them, or might not have the tools or the knowledge to analyze these. So it's really creating a national sort of technical committee and a steering committee to discuss that on a national level is extremely important. So I think these are the first steps identify and to go implementing the SEEA. Thank you.
Thanks. So we could maybe take one more question if either you can raise your hand and then you could ask the question yourself, or you can put it in the meeting chat. Yeah, so I see one more question by Inkyung Choi. Is it right that physical assets and services are transformed into monetary terms? Different countries value different services maybe differently. Is there a standard, or is it up to the individual country?
Yeah, that is a very good question. It's the correct. I mean, the provision of the SEEA is physical in first, looks at the environment in physical terms in the first, but obviously for the link With the national accounts, it is very useful to monetize that or to value that in monetary terms as well. So yes, the idea is that you develop a provision, supply and use tables in physical terms first, and then you can monetize them. The SEEA uses environmental models to model these, to buy physical models to model these. But then there's also a lot of economic models to value these services. We drew on a very large list of economic models that have been developed globally to value each each service, and there is a list of those that are provided in the SEEA. But also we've also developed a and I can put a link in the chat a little bit later, a guide for valuation of ecosystem services that goes more in detail into specific valuation techniques. One important aspect to know here is that because of its link to the national accounts, the notion or the concept of the exchange value is very important. So we do value ecosystem services from an exchange value perspective rather than from a larger welfare perspective, which is also a possibility, but the principle, the main principle, is the exchange value to maintain the link with the national accounts. Thank you.
Okay, thank you, Marko. Maybe we stop here with this first round of questions, and I would say I hand over now to Bram for the second presentation. Please go ahead.
Thanks, Alexander. So let me share my screen. I hope you can see it okay.
Yeah, looks good. Thanks.
Yeah, so to segue also into the demo on ARIES for SEEA, I wanted to say just a few words about the SEEA Ecosystem Accounting implementation strategy. So after basically the adoption of the SEEA Ecosystem Accounting as a statistical standard, we formulated a global implementation strategy with the overall objective to scale up the uptake of the SEEA Ecosystem Accounting by countries, with a suggested target of at least 60 countries implementing at least one of the ecosystem accounts by 2025. And it follows a number of main sort of principles that are listed here, such as, and I think Marko also spoke to that already, the importance of multi-stakeholder engagement at the country level, a flexible and modular approach, taking policy needs into account, things like South-South collaboration and a sub-regional approach, but also what we call a tiered implementation. So basically what we suggest is that countries could start with using, for instance, global data and global models to sort of quickly get to a result that can then be subsequently further improved, for instance, by substituting in national data. And it's for this, I think, tiered implementation that the work on ARIES for SEEA is particularly relevant. And so there's a number of activities in the implementation strategy. I think there's quite important is capacity building, and we have a number of e-learnings on the SEEA ecosystem accounts that actually are also should become available also in Spanish and French shortly. And then we also have released last year guidelines for the biophysical modeling of ecosystem accounts, with specific focus also on ecosystem services. So yeah, to add on to what Marko was saying, so I think so we distinguish between really the standard and then the guidelines. So recognizing that there will be flexibility and differences between countries, but yeah, I think this has gone through global consultation. So I think there's quite a level of convergence here. And then we have released also what we call a technical report on the monetary valuation of ecosystem services and assets for ecosystem accounting. This has sort of a lesser standing also because the monetary valuation in the SEEA ecosystem accounting does not have the same sort of status as the conceptual framework and the physical accounts. And then finally, we have also we also support countries with the development of tools. And yeah, ARIES for SEEA is one specific tool that we have been developing. So ARIES is an acronym, it's quite a mouthful. It stands for Artificial Intelligence for Environment and Sustainability. It's essentially, it's an application built on the existing ARIES platform, and the application is built by the Basque Center for Climate Change that is based in Spain, in Bilbao. The ARIES platform itself, I think, has been developed over the course of 10, 15 years through several research grants. So essentially what it does is that it uses all sorts of global data models to generate a basic set of ecosystem accounts that enables the user to compile basically those accounts anywhere on Earth. It's using a specific form of artificial intelligence called machine reasoning to construct what it calls the best available model for basically the problem specified by the user, giving the data layers accessible to the system. So I think that's a major sort of conditionality. It has many global data layers, also regional data layers, and also national data layers if countries, for instance, have made those accessible to the system. A large number of them based on Earth observation data. And it's intended to be a fully transparent framework in terms of, you can see the codes, the metadata, where all the data sources come from, and so on. There are two main sort of interfaces. So the one on the left is the ARIES for SEEA Explorer, and that's the one I would like to demo today. So basically it allows access to a web browser, and it's aimed towards non-technical users. But then there's also on your right what we call it's the K modeler. So basically that's a software that you would download on your own computer, and it consists of several components, and you would still have sort of a browser that then shows you the results of the compilation. And this on the right side is really aimed at technical users, where the users can contribute and what is called semantically annotate national data, also build their own models and so on. But it's using a specific programming language. It's called KLab, and I perhaps can say a little bit more about it later. Now I want to go to the ARIES for SEEA Explorer itself. So the easiest way to start is, so we have a landing page on our SEEA website, specifically on ARIES for SEEA, that provides some information about the application, but it also has a specific part focusing on how to access ARIES for SEEA. And basically first you would need to register for it, and then after you have registered and you have a profile, you can then sort of click here to access the application directly, which is not what I will do, because I will go a little bit through a different route through the modeler. But basically what you then get to, well, there's first the tutorial that I will click away. What you will see then is the basically it's a spatial interface, a map with a search bar here that you can type questions in. In your lower right, you have here a button that you can click on, and then you see which apps are available sort of on top of the ARIES platform itself. The interface currently is available in 5 different languages, but I'll choose English. So after you select your language, well, first of all, you get to this disclaimer, which I wanted to mention actually, because basically it says that, there's maps involved, and that the presentation and the designations involved in the ARIES for SEEA application do not imply the expression of any opinion on behalf of the United Nations concerning the legal status of countries and so on. I think this is quite important, and something that's sometimes a bit challenging, as we all know. I think there are disputes also between countries and territories. What is clear is that there is an official UN map. It's called the UN Clear Map, However, in the default application here, we use OpenStreetMap to provide an enhanced user experience. What you can see here on the right, there is basically a possibility to also select the UN Clear map if you prefer, rather than the OpenStreetMap as a background. The other thing I wanted to mention is here that it says beta, so it's really a beta version. So I mean, you will find, if you sort of dig in depth, things that may not work, or it could be further improved. Definitely, I think really we see this as a tool, you know, where we sort of collaborate as a community, where people can share data and models. So yeah, I want to make that as a disclaimer. Now, turning into sort of what it can do. So what you see here is sort of on the left side of your screen, you have sort of different blocks. So the first block is what is called context, where and when. So this allows you to basically to specify for which area of interest you would like to develop an account. You can select here map boundaries that would basically select, you know, sort of what you see in your screen, where you can, of course, zoom in, zoom out, and so on. You can also select what is called administrative regions. And basically what it then does is basically select sort of the best fit in terms of the database of administrative regions that ARIES has, you know, matching your screen. So here you can also move around, and then you will see it will find another area. You can also zoom in, then at some point will select subnational areas, for instance. It's also possible, for instance, to you know, select a river basin, if you like. And in the modular application, you can also sort of upload your own shapefile. So any polygon of an area of interest that you have, I mean, and it could be like, let's say, a project site or so. You could then also, you know, specify that boundary. But that's not yeah, that requires more sort of technical approach. Okay, so let's get back to the. So I'm decided to choose Ghana here, as we happen to do a project there at the moment. But I could, yeah, you know, select anywhere on Earth. You could also type in, for instance, a country here. You know, so that's a different way of looking than I would find in this case. You know, the sort of the concept of Belgium as a country. Right. Now, another thing that is important to know, so the second button here, it shows the spatial resolution. So if you, for instance, zoom in, you will see that also the spatial resolution here changes. So I think for most applications, we suggest to sort of stick with, you know, the resolution that is suggested. You can go down to, you know, like, you know, a resolution of 100 meters, but that will really exponentially, you know, increase computational time, and some oftentimes may not result, you know, an actual outcome if you really compile accounts at the national level. You can also fix the resolution if you like. And then the final thing to select is the years for which you would like to run your account. So it says now 2012 to 2019. I will select here 2015 because that takes a little bit less time. Okay, so that's basically specifying the area, sort of the context and the time period for which we would like to do the run an account. The next thing is, of course, then to actually select an account which we would like to run. So here you see the different types of accounts that Marko has also presented on before, extent accounts, condition accounts, and then we have ecosystem services accounts and physical and monetary units. So in this case, I would like to run now an extent account, and a specific one, a so-called net balance. And the moment you click, basically select an account, what you will see is that sort of the search bar turns yellow, and sort of the red dot starts spinning, which means that basically the application is drawing in and constructing a model. This should go very quickly, but now I think it takes a bit more time. So while it is doing, yeah, so I perhaps that's also something to mention, that sort of the speed, it depends also because it's also using the internet and so on. So it depends also a little bit, you know, it's not always that if you run a specific application that it will take, let's say, the same amount of time. So now what you will see is that you see sort of different things appearing here, elevation in meters, mountainous area, and so on. The reason it's doing that is because it has constructed a specific model to analyze this question. So we selected that we want to compile an ecosystem extent account. And to do it, basically ARIES has a model that is basically using what is called a so-called lookup table approach. Specifically, it's a multidimensional lookup table. So the idea of an extent account is that we would like to get a sense of the opening extent, in this case in 2012, of the different ecosystem types that you would have in Ghana. And then we have also the closing extent, and we want to assess changes over time. Now, how this works is that this lookup table is basically specifying for each pixel in Ghana what ecosystem type to assign. So, and it uses this table, for instance, land cover, if the land cover of a pixel is forest, if the aridity is more than 0.65, if the mean annual temperature is more than 18 degrees Celsius, etc., etc., we would find, or we would assign this specific pixel as tropical, subtropical, lowland rainforest, and so on. This is a very lengthy table. So in order to calculate this model, ARIES needs to pull in all these different data layers. So elevation is there, land cover, aridity, mean annual temperature, and so on. Whether we are in mountains or not, you can actually click also on each of these layers to find the metadata. So for instance, looking at the elevation, what ARIES does is that it takes this from the SRTM digital elevation models at 19-meter resolution. So all these data sources are basically described in the system. They're also all, in order to run these models, what we call sort of semantically connected to the ARIES ontology. So there's a basic set of concepts and definitions in ARIES where all sort of that links all data sources. Now we see some of these layers that have been pulled in. We can take a look at them also. So for instance, now I'm clicking on the land cover layer, and that should show up here. Takes a little while to, I think, to be picked. And in the meantime, perhaps show also elevation. Yeah, so this is, so basically what we see here is the elevation data layer that is pulled into the model. You can click on each, what is it, point in the landscape. You find the elevation of 100. I think here this is more mountainous, so here you find 244. So each of these layers, by clicking here, you can also individually download it. So all these layers are sort of clipped to the extent that you have selected, in this case Ghana. So another is, for instance, whether the specific area is a mountain or not. What do we have here? Mean warm month temperature and so on. Yeah, so these are the layers that we need to compile our extent account. So in the meantime, while this computes still, I wanted to show you a little bit more. So basically we selected here the ecosystem extent account, the net balance. But yeah, we also have, for instance, a change matrix. So that's really showcasing, for each ecosystem type, how much of it remains the same ecosystem type or changes in a different ecosystem type. We also have different, basically, land accounts that you will see here. In terms of the, we have also condition accounts that Marko presented on. Those are currently focusing on condition of forest ecosystem types, but we're eager actually to expand also into different other ecosystem types. And then, yeah, again, it follows the sort of the setup. So within the SEEA, we have 3 different types of condition accounts that are listed here. When it comes to, and let me close this because otherwise it becomes difficult to see. In terms of ecosystem services, we currently have about 5 models out there. We have things like pollination, carbon storage, soil erosion control, and the ARIES team is working quite hard to also include hydrological services like water flow regulation and so on. Okay, now the model has concluded. So basically the calculation has finished. So what it then shows basically is the net ecosystem account that we selected to compute. So what you can see here is that we have opening stocks, closing stocks, so 2012, 2014. And then we have here in the columns all the different sort of ecosystem types that it has basically modeled for Ghana. And then we see the changes over time. So what you see, for instance, is, well, this is an ecosystem type that's called urban industrial ecosystems. So basically these are artificial areas mostly. So yeah, we see an increase there, which is what you would expect due to urbanization and so on. But we see decreases in some of the, for instance, the natural ecosystem types like tropical shrubland and so on. So that was the output in terms of the actual account, the actual table. What ARIES also does is that it generates sort of on the fly automatically a report, which you can see here. You can, well, you cannot download, you can print the report at the moment, which gives you basically an introduction. Then it goes into the ecosystem extent model that is being used. In this case, we follow the IUCN's global ecosystem typology. It specifies then the methods. So this multi-dimensional lookup table that I showed you before is also part of the report. And then it also contains the results in terms of the figures, maps, and tables, and so on. It has also the references to basically what went into the model. And then it has also an appendix with some further disclaimers. You can see here the different figures. This is again, and it becomes a little bit botched because of the size of my screen, but all the data sources that ARIES has used to compute your query are also shown here. There's also buttons on the left here where you can download all the maps that I showed you and all the tables and so on. Yeah, one thing that I also wanted to show, but I'm not sure because it's a little bit slow at the moment actually to run. What you can see here, so here's the ecosystem type map that we computed. But as you can see here, there's also this small clock. What is it? Behind it. This is because essentially we selected the time series, so you can actually play the time series, and then you can sort of see also in sort of a time lapse, you can see the change in your ecosystem type. So you can see actually increases in artificial areas from 1 year to the other. So this is basically a demo of the extent account. We can also, for instance, yeah, if we would then sort of add on also an ecosystem service, what you will find is then that the model starts, computing again, and it will pull in and construct also a model to model, in this case, carbon storage, which is a way more complicated model, actually. Yeah, so for instance, for carbon storage, what you see here is that you would also need information, for instance, about soil carbon storage, so soil organic carbon maps. You would also need to have information about vegetational carbon storage, and so on. So then the model becomes more complex, but again, all using basically global data sources. So I think this is what I wanted to show on the ARIES for SEEA Explorer. So finally, quickly, also, I think picking up on some of the questions that we received beforehand. So the other interface is really what we call the modeler. This is the interface where basically you would need to program in this language called KLab. But if you want to integrate also national data sources, this is where you would do this. So there's a possibility to, for instance, you can construct different models. You can then, for instance, in terms of, it's called resources, you could drag and drop, let's say, your national land cover map and use that here. So that's what I've done, for instance, in case of Ghana, using national land cover data for 2019, 2021. But then you need to, what ARIES calls, semantically annotate this map. So you need, for each of the land cover classes in your map, you need to indicate which of the sort of classes in the ARIES ontology it corresponds. So that's what you would do in this model. So let me finally quickly check back on. So just wanted to say, so it's still computing, the elephant is still in a way spinning. But now for the carbon, for instance, storage, we see that we have also now, looped in data layers, in this case, soil carbon storage in tons per hectare and so on. Okay, I think let me stop here because I think I spent already quite a bit of time. I finally, in my presentation, I put here also some useful links, hopefully, with more information also about, if people are interested to become more familiar on ARIES, the landing page that we have on our website, but also the landing page in the ARIES website. So that's the second bullet. And also more specific information about how to collaborate with the ARIES team. So there's a wiki pages, Confluence pages. There's also all sorts of instructional videos that can be looked at and so on. And I'm also happy to touch people specifically in touch with the ARIES team that have a key interest in this. So let me stop share and I'll do it here.
Yeah, thank you, Bram, for this presentation. We still have a couple of minutes, I would say, to answer any questions that people might have. So if you want to take the floor, please raise your hand. Otherwise, we will just take a couple of questions that came up in the chat. Maybe let's start with two more technical questions. So there was a question is how the model takes uncertainty into account. And then there was another question about how the model handles missing data or missing layers. So you selected a couple of layers which you put into the model. How does the model handle missing layers? Maybe we start with that.
Yeah, no, that's a good question. So essentially, what the ARIES, how the ARIES team describes it, sort of that they, that the model constructs sort of the best available model for the problem, or basically they speak about the context, and they have some sort of a machine reasoning, which is in a way it's a little bit like sort of a Google page ranking algorithm. So it has a number of criteria. So, but essentially, I think what it does is, for instance, it prioritizes national data over global data. So, for instance, if you would run ARIES in a European country, it would use this Korean land cover data because that's higher resolution, higher number of, let's say, land cover classes. But if you are, let's say, in a country like in Ghana, it would usually sort of defer to the default, which is the ESA CCI. So that's a global map of 300 meters resolution. But then, of course, if Ghana decides to make its national data sort of interoperable with the system and share it publicly. So, and I think that's sometimes, the issue that there may sometimes be confidentiality issues for doing it. Then if somebody else would run, a query for Ghana, it would pick up on that national data. If that's sort of according to the machine reasoning, but in all likelihood it would. sort of be sort of preferred and chosen. So and then I think what you often see is, so I think if there's really no information available for your query, yeah, then I think it would not, yield a result. I mean, and another thing perhaps is sort of in terms of temporal data. So I think if you specify a query for a specific year for which there would be some data layer missing, I think it would automatically pick the closest sort of year in terms of time period. But sometimes you can run a query for, if you only look at the change between 2 years, sometimes you find no change, and that means basically that there was no specific layers available to map the change.
Yeah, thank you. And then there was another question, or two other questions, I believe, about tutorials and guides, how to use the K modeler and also the ARIES system. So maybe you can elaborate a little bit more on that.
Yeah, so perhaps, so I think we distinguish also between different audiences and different users. So what I showed you today is very much sort of the web-based version for non-technical users. And we think here of, that could be compilers, but it could also be, policymakers that just want to clip, sort of different data layers, to their area of interest, to their country or so on. To do the modeler, I think that really is more challenging. So yes, I think there's a sort of ARIES YouTube channel, and I think some of the links will also get you to these instructional videos. But I think learning the modeler and KLab, I think it's a bit like, learning how to drive a car. You don't pick it up in 1 hour watching a video. I think it really requires an investment. The ARIES team is organizing, and now I think in post-pandemic era, hopefully these in-person trainings. I think they are like 1 week or 2 week really immersion sessions where you can really, I think, become very sort of advanced in KLab. I saw a few questions also beforehand. I think we're really trying to build a community of people that really have an interest in it. But I think in that case, I think the best way would be, if there's an institution that says, yes, we really want to, start working on this, to assign, for instance, one person that then could really be, and have time to be trained and work with the ARIES team to become, versatile in this. And then this person could then, also train others. So that's, I think, sort of the model that we're sort of leaning towards these days.
Yeah, thanks for that. Also, I wanted to mention, Bram, I believe you had also prepared a short video, which we can then probably, together with a recording of this meeting and with the slides, we can share then on the global network. So people can have a little bit look at the different functionalities in this very short video that you have. Because, yeah, sometimes the ARIES takes a little bit longer for the calculation, so it's might be a little bit harder to show it now live. So there's one question. So if there are follow-up queries after the webinar, who would be the general focal point? So I guess it's you too, right? So people can reach out to you, Marko, and you, Bram. So this is for sure your point of contact, your first point of contact. And we are now about 5 minutes over time, which is not terrible, but I'm also conscious, or we are also conscious, that people might need to go to another meeting. So I would say if there are additional questions, please either reach out to Marko and Bram directly, or once we have posted the recording and the slides, you can also reply to that post, and then Bram and Marko can answer your questions in the chat or in the thread of that on the global network. So the only thing which is left now is basically, I would like to encourage everyone now, if you were shy before, to unmute yourself and switch on the camera, show your faces quickly, and give Bram and Marko a big round of applause. So please turn on your cameras. That would be really nice, and join me for a big round of applause. Thanks so much. this gives also a little bit more a human face to this sometimes very black wall of those meetings. So there are actually people listening. So this is really good to see. Thanks everyone for joining today. We have a couple of other global networks webinars coming up. Watch out for our monthly updates newsletter, which will hit your inboxes very, very soon. All right. Thanks, everyone. Have a
Thank
good,
you, Bram. Thank you, Marko. Bye-bye.
Have a good rest of your day. Bye-bye.
Thank you.
Bye.
Our pleasure.
Thank you.
Bye-bye.
Bye.
Thank you. Bye.